Hello, this is Mel and welcome back. This final video is about the regression applet. In this video, we'll examine ways of using this applet to explore linear regression, as well as some problems that might arise when using regression. You can find the applet here. This applet displays a scatter plot of two quantitative variables, as well as a regression line. The objective of linear regression is to try to predict a value of y based on a value of x. So, for example, let's say we know somebody's value of x, let's say it's 8. What's their corresponding value of y? This regression line gives us a way of making that prediction. Like all lines, a regression line has an intercept and a slope. It turns out that you can use the correlation between x and y to find the slope. If we use the standard deviation line option here, we can display the correlation between x and y, as well as the standard deviation of x and the standard deviation of y. The slope equals the correlation times the standard deviation of y over the standard deviation of x. In this case, 0.96 times 1.87 over 3.17. Eyeballing it, it looks approximately equal to 0.56. You can interpret the correlation in the following way. For every one standard deviation increase in x, y increases on average by 0.96 standard deviations. That's quite a lot. And that suggests that x is a good predictor of y. As a reality check, we can look at the scatter plot, which seems to support this statement. Okay, let's take a look at an example in which the correlation is weaker. As you can see, the correlation is negative 0.76, which is weaker than 0.96. In addition, the slope of the dotted standard deviation line, negative SDY over SDX, is steeper than the slope of the regression line, which is negative 0.76 times SDY over SDX. The weaker the correlation is between the two variables x and y, the closer the regression line gets pulled just to the mean of y. In other words, the weaker the correlation, the better we'll do simply guessing the mean of y for all values of x. Another useful display option you can use on this applet are these residuals. Residuals are basically how much error you have in your prediction. So as you can see, the regression line makes a certain prediction, and the actual points are some distance away, and that distance is your prediction error or your residual. We can use these residuals to investigate cases in which linear regression is not a good way of describing the relationship between x and y. For example, if we use the quadratic option here, we can get some examples of scatter plots in which the relationship between x and y is quadratic. As you can see, not only are the residuals quite large, but there's also a distinct pattern in how they're arranged. For small values of x, the linear regression underpredicts the values of y. For middle values of x, the linear regression overpredicts values of y. And finally, for larger values of x, the linear regression underpredicts values of y. Obviously, there's a quadratic relationship between these points that's not being captured well by this linear regression. Finally, linear regression can be sensitive to influential points. Why are they influential? Well, I'll show you. So here we have a linear regression on the scatter plot, and if I add a point that's far away from the line, we see that the linear regression line changes dramatically. As you can see, this handful of points has changed the regression line by quite a lot. That's why it's so important to use a scatter plot to visualize the relationship between x and y, instead of simply relying on the slope and intercept calculated from a computer program. By visualizing, you can help identify problems such as nonlinearity and influential points. Okay, so to summarize, we talked about linear regression and how the slope from a linear regression line is related to the correlation between two quantitative variables. And we also talked about some problems with linear regression, including nonlinearity and influential points. I hope this video will be helpful for you in your curriculum. If you have any questions or suggestions about this applet, please let me know at mao.hu@duke.edu. I quite enjoyed making these applets and these videos describing them, and hopefully for the next section, of course, I'll continue making some applets and videos to help you incorporate them into your students' learning. Thank you.